Welcome to The Explainer. Okay, we are diving straight into a tech world true crime autopsy today. We're going to look at a wildly successful AI demo that inexplicably led to a completely dead project just 3 months later. We're breaking down the actual anatomy of AI deployments on the factory floor, and we're going to figure out why building the model is honestly the easiest part of the whole job.
So picture this. Our story starts at Cardinal Polymer Systems. They manufacture plastic components for the auto industry. The VP of operations there sees a competitor's press release, gets inspired, and hires a forward-deployed engineer to set up a computer vision defect detection model on line 3. 6 weeks in, they run a demo, and it is flawless. I mean, the model is catching defects that human operators completely missed. The VP is absolutely over the moon. But fast forward 3 months, and she is left asking this incredibly frustrating question. We shipped. Why didn't anyone adopt?
We've all seen this happen, right? There is this massive, stark contrast between the tech working perfectly in that 6-week demo and the grim reality 3 months later. Out on line 3, the operators are just back to using their old manual processes. And the AI model? Yeah, it's been quietly turned off. The operators complained it was flagging way too much stuff, the actual project owner was never officially named, and the floor supervisor hasn't even opened the tool in over a month.
All right, so to solve this Cardinal Polymer mystery, we need to jump into Section 1, the implementation lifecycle and its 4 stages to adoption.
We're going to borrow a bit from Six Sigma's famous DMAIC process here, but we're compressing those standard 5 steps into 4 very specific stages for tech deployment: diagnose, prototype, evaluate, and adopt. Let's walk through exactly how each of these works, and more importantly, how they completely fall apart.
Step 1 is diagnose. Now, what's truly fascinating about this first stage is that it demands we hit pause. We have to locate the actual system of record and compute the exact cost of an action before we write a single line of code. We aren't building yet. We're mapping the workflow and asking, where does the work actually live day to day?
But here is the catch. The classic failure mode in this stage is jumping straight into solutions. You can literally spot this a mile away when an engineer already has a model architecture in mind before they've spoken to a single line operator. If your discovery brief doesn't explicitly spell out the financial cost of doing nothing, or you've accidentally identified the wrong software as the system of record, well, you've already failed the diagnose stage.
Okay, moving on to the prototype stage. This is all about focus. Our one and only goal is to ship a working, highly focused version of the tool, what we call the narrow path, and write those outputs directly back into that system of record we just found.
How do you know you're messing this up? Well, if your quote-unquote narrow path has quietly turned into a 10-lane highway, and you're focusing on polishing before instrumenting, if your user interface looks incredibly pretty, but under the hood your logs are missing basic stuff like inference latency or structured output schemas, you've completely lost the plot of the prototype phase.
Next up, evaluate. The core question here is basically generating proof. Can we actively prove it works, and just as critically, prove it's safe enough to leave running? This means building a rigorous evaluation suite packed with golden examples of data, bringing in red teams to try and break the system, and publishing a rock-solid security stance.
The absolute biggest trap here? Skipping all these checks, because the prototype simply looks fine. Listen to me, looks fine might just be the most expensive 2 words in this entire industry. Because skipping this, if you don't have an eval set, or the customer security team hasn't seen anything in writing yet, your team is already chatting about rollout, you are basically begging for silent regressions the second you deploy.
Finally, we hit the adopt stage, the ultimate litmus test. Are the operators actually using this thing on day 2, entirely without us in the room? This doesn't happen by magic. It requires a documented 30, 60, and 90-day enablement plan, establishing a very specifically named Day 2 owner, and running deep technical training for your super users.
And this brings us right back to our true crime scene at Cardinal Polymer. A massive chunk of projects actually die right here. Not because the tech is bad, but because the team treats adopt as just a box to check instead of the final destination. They confuse shipped with adopted. The demo goes great, sure, but nobody gets trained, no owner is named, and the operators just silently go back to their old manual spreadsheets.
Here's the real secret of this whole life cycle, though. It is absolutely not a straight line. It loops constantly. Discoveries you make in the adopt stage are going to send you right back to diagnose. Things you find in evaluation will kick you back to prototype. Just remember, a clean, linear run isn't proof that the project was easy, it's usually proof that you just stopped looking for the real problems.
Which perfectly transitions us into Section 2, Artifacts Tell the Truth. Specifically, why we need to read the verbs, not the nouns.
Let's look at some actual evidence from Cardinal Polymer. Slides and presentations are literally designed to hide the ugly truth. To diagnose a project, you have to read the raw artifacts. Take this totally standard Slack message at 9:14 a.m. The engineer says the QC operator showed them the spreadsheet they actually use, and it's not the one in the manufacturing system. We have to ask, what is the engineer fundamentally doing in this exact moment?
If you just skim it, the noun in that message is the spreadsheet, right? That's just the tech. But look at the verb, the action of actually learning from the operator that the workflow uses a completely different system of record. That proves this is a textbook diagnose move. The engineer is learning, they aren't building.
Now compare that to an artifact from a project that actually succeeded. We've got an Arise Phoenix dashboard link here. It's got 200 golden examples, 4 specific metrics, and an active continuous integration regression gate. This right here, this is the holy grail. It's a canonical artifact that actively prevents a prototype from regressing silently in the background. See, the noun here is just the link itself. But the verb, it's actively proving the system works and gatekeeping regressions. The complete lack of this exact evaluate stage artifact is precisely why Cardinal Polymer's AI model was quietly put in the grave by the operators. They totally skipped evaluate just because their demo looked fine.
Okay, this next one is super tricky. It's a Slack message saying Mary, an inspector on line 3, has been using the tool for 2 weeks and found 6 false positives. Naturally, because you see the phrase false positives, it sounds exactly like an evaluation metric. You'd think this belongs in the evaluate stage, right?
Not quite. The definitive action here, the actual verb, is that an operator is actively using the tool on the factory floor for 2 continuous weeks. That makes this a clear, indisputable adopt stage signal. The fact that she found false positives? That just means the adopt stage has naturally triggered a loop back to evaluate.
Let's wrap this up with Section 3, shipped is not adopted, and the final tests you absolutely have to pass.
So why did Cardinal Polymer really fail? It boils down to this. They confused a killer prototype demo with actual organizational adoption. They basically threw a party at the 80% mark. But adoption isn't just a software push. Adoption is a person, it's a metric, and it's a 30-day window. You only actually pass this stage when you have a named Day 2 owner, a measurable business signal that has moved, and operators like Pam Cheng, the QC lead, running the whole new workflow entirely without an engineer hovering in the room.
The golden rule to take away from all of this is simple. Read your project's artifacts, not its slides. You have to learn to read the verbs in Jira tickets, in GitHub commits, and in random Slack messages. Slides are beautifully designed to tell you everything is fine. Artifacts, though, artifacts tell you the truth.
So, I'm going to leave you with this thought to mull over. Take a hard look at your current project. Look at your most recent artifact. Identify its verb and ask yourself honestly, where does your demo say one thing while your artifacts are screaming something else? Which lifecycle stage are you actually in right now? Thanks for joining me for this explainer, and I'll catch you on the next one.